problem number 1, there was a part there where the varying load is somewhat like this, no? Then the point C is right below the zero slope. Now remember that gamma will always come from the perpendicular global y-axis at point C, pointing towards the maximum slope clockwise. So this would be negative gamma, diba? Then from the line pointing the maximum slope towards the minimum slope or the zero slope would be the location of your alpha. So from gamma, punta doon. Okay? So therefore, gamma would be equal to alpha. Yes? Kaso nga lang, convert mo lang into radian yung alpha. Then degrees pa rin yung gamma, but negative. No. So probably that is where you made the mistake on your computations. Now, with that, we move on to Unit 7. Nakuha nyo naman yung assignment. So with Unit 7, we have Unit 7, vertical stresses below the center of a uniformly loaded circular area. This is, for instance, we are now using a circular load or a circular pavement placed on top of a soil, or even a circular mass of soil on top of a flat terrain of soil. Basically, this would be distributed uniformly but in a shape of a circular load. So with that, you have a vertical stress below the center of a uniformly loaded circular area. Like so, a simple example would be a circular or a circular footing. Okay, so if we have a circular footing of such dimension, of course, this circular footing would cause a vertical stress on the underlying soil below the circular footing. And that stress would be based on its load or carried load based on the upper vertical structure. And that would be in the form of a circular load. Okay. Now, this is when the stress is concerned is right at the center of this circular load. So for instance, now, if the focus point or the soil mass we are concerned is found at the center of the circular load. Like so, this would be the equivalent radius r of the circular load that is uniformly distributed. And the point at which the soil mass in concern would be the depth of Z. Okay, nasusundan. That would be your point A, such that point A will have a coordinate point of r is to Z. Nasusundan. Or with this case, nasa center kasi siya, so this would be 0 is to Z. Okay? But the next unit lecture or the unit 8 is basically when the point concerned below the circular load is no longer at the center. For instance, nandito na yung ating point concern. This is a point A. Therefore, this would result to another value of r, which will be your small letter r. What would be the effect of a circular load at this particular depth, say, of point A? With that case, kung ganito, if no longer center, A has a coordinate of small letter r at the depth of Z, which requires us a different set of formulas. But for now, if the point concern is at the center, okay, at the center of the circular load, the increase in vertical stress would then be computed as, again, the vertical stress Q times the applied load Q times 1 minus 1 over the radius of the circular uniform load all over the depth of the point of the soil mass Z squared plus 1 raised to 3/2. That is through the use of the formula. But if we were to use the table where delta sigma Z is also equal to C, or over Q is equal to C, therefore, the use of the table would just be, or the vertical increase in stress would just be C times Q. Saan manggagaling yung C? That would just come from the ratio of Z over R, where again, Z is the depth of the point concerned. And R is the radius. Do not forget that capital R is the radius of the circular load. Nasusundan. Capital R is the radius of the circular load. The ratio would then equate to the equivalent value of C. Then multiply that to the Q, gives you the increase in vertical stress. Like so. We have a simple example. Again, a flexible circular area, again, on the ground surface is subjected to a uniformly distributed load 105 kilonewton per square meter. So this circular section or circular load is distributed uniformly as 105 kilonewton per meter square or kilopascal. If a circular area has a radius of 3.6 meters, determine the vertical stress increase at 0.0, meaning at the center of the circular area, below, right below the ground surface along the center line of the circular area. With that being said, on example number 1, sabi niya, kung meron daw tayong circular load that is uniformly distributed on top of a circular area. Okay, uniformly distributed from center has a radius of 3.6 meters. We are asked to determine the increase in the vertical stress right below the circular area, meaning at this point. No? Nasusundan. So therefore, what will be the depth of Z? What will be the depth of Z? Right below the surface of the circular area. Z would be equal to 0. Okay? Such that the location R, or the, what do you call this? The point concerned, or point A, is simply at equal to 0. Or the coordinates of A would be 0 is to 0. Nasusundan natin. Now, using the formula, so pag top view, ito naman po itsura niyan. So at the center with the radius of 3.6. And at the center would be your point A. Okay? So by formula, the increase in vertical stress at point A, right below the circular load would be, again, your Q of 1 minus 1 over R over Z squared plus 1 raised to 3/2. Nga pala, yung value ng ating Q, circular stress load. The circular load would be 105 kilopascal. Well, using the formula, we substitute. The increase in vertical stress would be 105 times 1 minus 1 all over. Capital R would be the radius, so that would be 3.6 over the Z of 0 square plus 1 raised to 3 halves. So what is sigma delta Z? 3.6, Z is 0. May binigay pang value para sa Z right below eh. At point 0 below the ground surface along a center line of a circular area. Oh, okay. Just give me the value. Then using the table, that would just be Z over R. So 0 over 3.6 equal to 0. So if we were to use the table, that would just be equal to C equal to 1. So the increase in vertical stress at Z equal to C times Q. Okay, so that would be 1 times 105, or this is 105 kilopascal. Tama ba? Tama ba? Therefore, obviously, this is also 105 kilopascal, right below nga ng ating circular area. So walang masyadong increase dyan. Exactly as the circular load. Sabi nga natin, right below. So as the depth increases, obviously, this load would also increase later on. Nasusundan. Okay? Ay, tapos na. Sagutan na lang natin to para pandagdag. Don't mind that as an assignment. Let's just answer this one then. What if the second scenario would be if the Z is now given? No? So in this case, a flexible circular area, same figure, with a radius of 3.6 meters on the ground surface is subjected to a uniformly distributed load of Q105 kilopascal. If the circular area has a radius of 3.6, we are asked to determine the vertical stress increase at 0.7 meters below the ground surface along the center line. So similarly, along the center line for number 2, similarly along the center line, you have the same increase of vertical stress load would be 105 kilopascal. 105 kilopascal along the center line at a radius of 3.6 meters. Then located at the depth of 7.2. Ito daw yung depth of point concern, which would be your Z of 7.2 meters. Nasusunod. Therefore, the coordinates of A would just be 0 and 7.2 meters. Nasusundan po ba? So ito yung ating point concern. So therefore, if that's the case, if we were to use method 1, using the formula, direct substitute nyo na lang, increase in vertical stress is equal now to the Q of 105 kilopascal times 1 minus 1 all over R. What would be your capital R? That is 3.6 over 7.2 square plus 1 raised to 3 halves bracket. So the increase in vertical stress at point A is equal to 99. 29 point 868. Okay? So 868 kilopascal. As you can see, this would be 29.868 kilopascal. Ako pala bababa, distribute niya. Okay? Using the table naman, using table, that would be Z over R, which is 7.2 over 3.6, which is equal to 2. So if Z over R is equal to 2, using the table, what would be the value? Z over R is equal to 2. C is equal to 0.2845. So 0.2845. Therefore, the increase in vertical stress, C times Q, 0.2845 times 105. The increase in vertical stress would be, parang increase to change. So as the depth increases, therefore, i-add ko lang yung 105 plus ito, as 7.2. Kasi nga, delta pala. We're talking about change in stress. As the depth increases, obviously, yun yung kailangan natin, yung total stress later. What will be this one? Same, no? 20 or 30? 29.878. 873. Parehas lang. Decimals lang yan. Kilopascal. Almost the same. That's just because we use the table. No need to include that on your assignment or second assignment, including the unit 8. Okay? Nasusundan po. Now, similarly, under unit 8, same lang. It's just that this time, the point of the soil mass concern is no longer at the center line. Okay? It's no longer on the center line. So paano kung hindi na siya at the center line? Of course, we will now be able to change the formula into Q times A prime plus B prime. Wala ka ng option. Okay? It's just that you need to use the table to determine both A prime and B prime at the same time. Wala ka ng ibang option with regards to the formula for the vertical increase of stress. Okay? Now, it's this time, rather than focusing at the center point, therefore, point A would have a specific coordinate. A, pag hindi na siya center line, would just be equal to small letter r times Z. So again, on the circular load at the center, The radius would be the capital R. Then the point concern would be always outside the circular area of load. Let's just say here is your point A. That would be your small letter R at a depth of Z. Nasusundan. Okay? Yun lang naman ang pinagkaiba nila. It's just that with this one, we need to check two values or two set of tables. The table for A prime, where we need to check the R over R, or small r over capital R, and Z over capital R for both A prime and B prime. Nga pala, the arrangement of the table, from this one, idugtong niyo po ito doon sa kabilang side. Kikita yun? 2. Okay? Lahat ng nandito, along 0 onwards, are the values for R over R. Lahat ng nandito sa column na to are the values for Z over R. Idugtong yung susunod na table after ng 2 dito. Kasunod ng 2, itong table na to. So diretso yan, from 0 to 14. So mahabang table lang talaga yan. Then ito yung katapat ng Z over R. That is for the determination of A prime value. Then this is for the table of B prime value. Same pa rin, 0 to 14, then 0 to 10. Dugtong doon sa 2, yung 3 to 14. Susundan. Okay? So, through the use of the table, if, how we're going to use the table, if for B prime, R over R would be 0, and Z over R, let's just say 9. So therefore, the value of B prime would be 0.01212. Okay? Intersection lang yan. Let's slide the example. Similarly, if you have the similar load or a flexible circular area of a radius 6 meters is uniformly loaded by a 450 kilopascal circular load or uniformly circular load, determine the increase in vertical stress at point A. At point A. So ang point A natin, right at the edge of the circular load, at a depth of 6 meters. So again, you have the circular load, which has a vertical stress of 450 kilopascal. Okay? Then from the center of the circular load, it has a radius capital R of 6 meters. It was found out that right below at the edge of the circular load is the location of point A, where point A is at a depth of, from the surface, at a depth of 6 meters. Okay? At a depth of 6 meters. Therefore, the coordinates of A would be small letter r times n Z, which would be equal to 6 is to 6 meters. But with this case, yung capital R natin, or the radius of the load, is 6 meters, which is the same as the location of point A would be 6 meters. Nasusundan. Now, for us to use the table, again, we need to determine the values of A prime and B prime using table 3.7 and 3.8. Using 3.7 and 3.8, both of them uses the same variables, where, again, ito pala yung Z natin, 6 meters, where we need to determine the ratios of Z over R and small r over the capital R. So that would be 6 is to 6, 1. Then 6 is to 6, which is also 1. If Z over R is 1 and R over R is 1, using table 3.7, A prime would be equal to, and using table 3.8, A prime, then B prime, gamitin natin yung table, 1 is to 1 lang naman siya. 3.7, 1 is to 1. 1 is to 1. 0.17868. Gamitin yung buong decimal number dyan. 0.17868. Nasusundan. Then for B prime, 1 is to 1 ulit. 1 is to 1. Tama ba? Yes, 0.15355. The B prime would then be 0.15355. With that, therefore, the increase in vertical stress at point A, again, would just be Q times the A prime plus B prime. This unit module is one of the simplest stress analysis. Dali lang. No? Unless kung wala sa table, anong gagawin natin? Interpolate. So 450 kilopascal, unitless naman yung A prime and B prime. That would be 0.17868 plus 0.15355. Okay? So therefore, the increase in vertical stress due to a circular load at point A, at the specific location of point A, is what? 149.50504. Okay? Kilo Pascal. Okay? This would be your final answer. Nasusundan po. Malinaw. Children, malinaw. Yes. Again, huwag nyo na rin isama sa assignment. Tapusin na natin. Madali lang naman siya. Hindi siya worthy as assignment. Okay, let's finish this one then. The last, instead of an assignment, let's just answer the problem. A flexible, again, circular area of radius 6 meters, uniformly loaded with 450 kilopascal. Determine the increase in vertical stress at point A. If point A is moved at a distance from the center of 12 meters at a depth of 3. Napalitan lang naman yung location ng ating point A. For problem number 2, similarly, increase in vertical stress is increase in vertical load, or the vertical load is the same as 450 kilopascal from the center. The radius of the circular load was the same as r equal to 6 meters, but this time the location of point A from the center of the circular load was now small letter r equal to 12 meters. Then this would be the new location of point A at the depth of z, at the depth of z equal to 3 meters rather than 6 meters. No? Pinalitan lang. No? Similarly, that would be the location of point A with a coordinate of 12 is to 3 meters. Same formula. Again, kunin lang natin yung ratio ng z over r and r over r. That would be 3 over 6, or this is 1/2 or 0.5. Then 12 over 6 meters. 12 over 6, that would be 2. Okay? Using table 3.7 and 3.8, again, table 3.7, solve for determine A prime. Then table 3.8, we determine B prime. Diba? Saglit lang. Oh, that is 0.5 and 2. Malayo naman, nasa dulo. 0.5 to 0.03701. Tama ba? 0.5, Z over R. Then R over R. 0.03701. 0.03701. Kunin yung buong decimal. Then for B prime, 0.5 ulit. Sa dulo, negative 0.02651. Negative 0.02651. Tama ba? Yung nakikita ko? Tama ba? Yes. Apat na ang mata eh. Oh, next. Oh, similarly, the increase in vertical stress would just be Q times A prime plus B prime. So this would be 450 kilopascal times A prime, 0.03701, plus minus 0.02651. What is the increase in vertical stress? So this is when A is at 6 is to 6 meters, and this is when A is at 12 is to 3 meters. Ilan to? Ilan po? Ha? 4.725 kilopascal. Okay? Pare-parehas ba kayo na nako-compute? Yes? This would be your final answer. Again, for your quiz this Friday, Unit 1 to Unit 8 of Module 3, Stresses in a Soil Mass. Bring your tables from Module 1 to Module 8, all tables. If you wish to use the table, then, again, sabi natin, pag wala sa table, formula. Huwag ka na mag-interpolate kasi nadadali tayo sa interpolate. Pag nasa table, gamitin mo yung table. Pag wala sa table, gamitin yung original formula. At least maikli pa yung formula na i-memorize natin. Kukunti lang